So.
I need to clean this up a smidge.
Yeah, but it's
But like,
starter, and I'll play something in room 2. Maybe we should tell this.
I feel like we could consolidate general performance. I'm just taking some things from like the document.
Yeah. Oh, yeah.
There's also important.
So.
What is it?
We are live right now. So if, here we can take this and essentially just. What I'll do is just I'll mute these.
Mm-hmm.
So we'll just mute both of these. And what I'll do is I'll just deal with this post-production.
Okay.
Are these?
That's the...
Okay. So here we can probably close up a couple of these windows. So that will be a studio. You've already done that. That's good. Essentially anything that you don't want anyone to see in the background, because
I don't think
your entire screen right now.
I can close that.
Probably close that one. Probably that one. Beautiful.
Okay.
Awesome.
All right, let me just go through the presentation so I remember what I'm talking about.
Oh, you're good. You're good. Thank you.
No, not at all. Do you think that's big enough on the screen? I mean, I know internally, I'm sure here it'll be fine. But
No, I was just thinking it's small. You can barely see it.
how about that?
I'm just thinking how big I feel in this room. It's such a small space.
It does have high ceilings.
If the high ceilings make it huge, if this room, there's an alternate universe where this room ceiling is like half as tall and the room feels like a quarter as big.
Right? Now all you're missing is like the big doors you would find like in a communist space where like the big doors that make you feel so small. Like you get to open up. I don't know if you've ever been to China or
Yeah, it's one of those things
It's
you go.
commie blocks. Or,
Yeah.
well, it's Khrushchevska, Brzezinska, and Stalinka.
okay.
I'm Lithuanian, so I just know.
Oh.
They were under the communists for a long time.
Oh, so you're well aware of this. I did not know.
Oh
that.
yeah, oh
So
yeah.
you know exactly what I'm talking
Oh
about.
yeah.
So
I spent a lot of time in one.
So you're on the. You grew up on the other side of the block.
No. I grew up here in the
You grew up
States.
here?
Yeah,
Okay.
yeah. But my family is from there, and I would go there. Is there a presentation mode? Where the hell is that?
For
PowerPoint.
right here.
Oh yeah,
So-
slideshow.
So you can. Yeah, there you go.
Okay, because that'll be the only time I.
Here's the questions that
Yeah.
here's the agenda set. I think really I do think the most important thing is going to be like the network conversation.
Yeah, because you know what? I don't want to make it too polished either. Like, I don't want this to be a marketing event. This is just. I actually threw a lot of these slides together. Like these are.
No, this is
Yeah,
great.
all right,
This
yeah.
is what I was hoping for. And
Okay.
you know what? You do you. If it's polished, that's great. If it's not, I'm pretty confident no matter what, even if you're not polished, you're going to be better than some of the other topics I've had.
Okay,
I'm curious.
And I'm sure
After you're done, after we're done, how I was gonna get ranked. Where?
Oh, so like I had one speaker I coached for 2 months before he gave a presentation, and he still broke all the golden rules of speaking.
What are the golden rules of speaking?
What? Okay, don't talk about politics, don't talk about religion, and don't talk about child molestation. Like, I just thought it was like a simple.
It does seem. Actually, one of those three.
No, he broke all three. It sounds like.
Oh my God! Since the event has not started yet, so Andrius and I drove up together, and I have just a basic Model 3. But I don't know if you've been paying attention to the news. Elon's been in it, and I bought a bumper sticker that says I bought this before Elon went crazy.
Yeah.
Because this is not the Elon I bought my car from like 3 years ago. And literally we were stopped, and I was like, I'm going to a work event. Better take out the political bumper sticker. The most unassuming bumper sticker in Madison,
Well, I think it probably plays well in Madison.
In Madison, are you kidding me? Like,
Especially after everybody gets around here.
No, actually, this is an incredibly liberal state.
No,
I mean, not state, it's the area.
city.
No, that's why I'm the joke is like, this is like walking into like, a pillow factory, like no one's gonna have a problem with it, but I was still like, work thing, I better just take this off, right?
We'll be standing in front of your Tesla, it's on fire, and we're gonna make the news, like, hey, what are those two guys doing there?
All you had to do was leave that bumper sticker on.
It's funny,
They actually worked against you.
Instead, you try to like overthink
Yeah,
it.
this is the city where they burn in reviews.
Does Vast Insurance cover my car?
What's funny is I have a very nosy, elderly, like old gay doctor neighbor who like he's an immaculate house. I got little kids. We got like plastic shit in like backyard. Like it's an all American backyard, right? Or like there was a hole in the roof of my garage, and it's very far down on the 2 pixels. And he's like, hey, you still got a hole back there. I'm like, it's facing the alley, man. Like I don't know what to tell you.
Thanks for pointing it out.
I will get to it at some point. But he was confident. He's like, oh, are you gonna keep driving your Tesla? Like, are you worried about people?
God.
Aren't you worried about people like messing with it? And I would point to my little like magnet. It's like, no, I got my protection device over here. I keep this magnet on it, and no one messes with it.
Yeah.
And now I'm realizing I took off my little protection.
Yes, yeah. It's good luck. You're on your own now.
Yeah.
You had your shield.
Although-
you took it off. Oh my gosh.
Although I think I made Andrius. Self-driving is pretty great.
It is, I
For
was
$100
shocked.
a month?
It was, I've never, it's cool.
Yeah, very cool.
Until it's not.
What's funny is we were on the last exit to get here. It's like it's like 99% there, and the last and sometimes you'll test it. Like we got here early,
Yeah.
right? So we're like, let's see how it handles it.
Let's floor it.
Maybe a last minute transferring the exit to go up the highway. So 99% there.
And it didn't like veer you into oncoming semi.
No, just wait until the last. And there was no one in the exit lane, but we're just like, I want to see what it does. And then like highway's going here, exit's going like that, and we're like here, and it's like, I better get over. I'm like, so. Andy, I like those shoes.
Thank you. These are going to be, I'm going to be wearing these a lot.
What are they?
They're Jordan 1.
Oh, okay.
I can't remember, but they're Flyknit.
they're Nike,
But yeah, they're the Flyknit material, so they're super like breathable and light and.
And then there's not a lot of weight.
And I found them really cheap on StockX, like below retail. I was like, great.
Did I think I mentioned this to you. You guys
Check the
probably heard
algorithm.
this. My wife and I are trying an experiment for May. I think like every other American, we have like too much stuff in our house, like just too much junk, right? So we've been trying to get rid of it. We're doing like minimalist May. We're like no buying.
Is that a thing? Minimalist?
We made it
I
up.
like
We're
it.
like, so like here's the thing. Like we still like we went to Costco and got like food this weekend. If our kids need a pair of shoes, right? Like we're like her birthday's this weekend. Mother's Day, we're gonna go to dinner, right? We're not like depriving ourselves, but like before I buy anything to come into my house, like no, like you're not buying anything non-essential.
You need a trade out, right?
Not even trade out, like no new shoes, no shirts, no picture frame, like whatever the dumb thing that everyone runs to Amazon. You're like look back through your Amazon history and you're like, oh shit, I forgot I got that. I forgot I got that. Or something shows up.
All
and you
the
forgot you ordered it.
$20 items add up.
Yeah. So we're like, so minimalist May, like let's go through the whole month without buying anything. I mentioned this because I found a pair of really nice Nikes.
Yeah.
And I was like, I really want to get these. I'm like, minimalist May.
Yeah.
Hopefully they're still on sale.
Yeah, put it at June 1st, remind
If
you.
you want, I just have them shipped. Like,
If you want-
Delayed ship. Delayed ship, yeah.
Actually, what's funny is we bought
Don't charge me till.
we're turning part of my office into like the family office, like family library. And on eBay, I found like a 100-year-old pencil sharpener. It says like Chicago, pencil company, right? It was like $12, right? And I ordered it. I put a bid in like a week or two ago, and then I got an alert like on Sunday, like, hey, I want a pencil. I want my, And she's like, what happened to Minimalist May? Like, what are you doing? Because we're shipping. It's like you spent $20 on a pencil sharpener. I was like, no, I put the bid in April, so yeah.
Anything else we should know about the event?
about the event, people start showing up usually 15 minutes beforehand.
Cool.
Through start of the event and then after. And pizza should be here.
Hello?
Hello.
Come on in.
Speak. Didn't I say it like 15
Yeah,
minutes before?
perfect.
Perfect. Come on in. Thanks for coming.
You guys don't bite?
Not
No.
hard.
Okay, that's good.
Well, one of us does, but good luck figuring out who it is.
That's a good. Tricky. I'm Brett.
Chris.
Chris, nice to meet you.
Andy.
Andy, nice to meet you.
Andreas, how are you?
Andreas, you said?
Yeah, Mike.
Mike, nice to meet you. Oh, yeah, so.
Right.
Come sit.
Looking forward to it.
Speaker or?
No, this will be the actual speaker. I'm just logoed up, I guess. Yeah.
No.
Yeah.
So you're an organizer, right?
I tried.
You have that kind of smell. Just kidding. No.
You better be careful, he's actually the one that
It's
bites.
the intellect smell, right? I bow before thee.
Did Ian say when they're gonna come to drop it off?
No, they didn't. They did say they were delivering. And I said, oh, I thought you were dropping off. And then he said, oh, no, I have it marked for delivery. I said, okay, I assume that's correct then. If it's
They said
incorrect,
it
we
was
will contact you.
$5 and they'll bring it here. And I was like,
Yeah, and I tipped the driver too, so. Yeah.
You can see Ian's.
Right,
Literally,
right. Still give it.
It's right there, right?
Oh, is it?
Still give it tip
I
though.
actually just remembered, I have a buddy that was going to invite to this thing, he works at Pure, he's like, last play did Arctic, he's in Madison,
Oh.
and Texan's a competitor.
Yeah.
But he's like, he's a good, good guy, very technical, and I was going to invite him, and I totally blanked, and then you're like, Ian's Pizza, I'm like, oh shit.
But yeah, I don't know what time.
Okay. Yeah, I
What
mean,
did
I
he
told
speak
the,
for?
I told the guy that, our event is at 6, if you could be here early, that'd be great, and,
Okay.
so whenever they show up, they show up. So,
I have the number. If it gets to a certain point, we'll just call him.
or I'll just walk over there.
We'll just walk over.
Where is, I mean, is it just
No,
right?
you guys are the important ones.
So, it's
all.
the brick building right over here. Not the
Oh,
one
this one.
in
You
the
can't
front,
see- you
but
can't
the one
see
on the
that.
side.
Oh, okay.
Yes, on the other side. And this is Station, this is the head of State Street right here. There used to be a building over here, there used to be one of my favorite bars right here, the Silver Dollar.
Oh, yeah. Which was.
Did you go to Madison or did you go?
I just grew up here.
Oh,
And I went
okay.
to college, came back after college, and then moved to Chicago in 2004. Relatives still here, I came back to go.
The Silver Dollar was one of my frequent bars in college, because it was cheap.
Do they still go crazy on Halloween? 'Cause when I was in college, it was Halloween.
Oh my God, yeah, like, they
I've seen
haven't,
some stuff.
they haven't had a lot of tear gas lately.
It makes for a great effect. It must just be more cost affordable than fog.
And when they show up on horseback, like, they just think it's a prop. Like,
Oh, yeah, it's, more exciting that way.
yeah, those were, that was a different time. Things are a lot more chill. Yeah.
Well,
For-
it's pretty warm today,
Oh, I wasn't talking yet. Nice, nice.
but replace the D with a B jokes.
So, there's swag if
Yeah.
you're interested.
Yeah, socks.
Oh, let's
Might
see.
wanna hear from us first at some
Socks.
point, but grab it now and put it
Wait,
back later if you don't
aren't
like
there
what we
a
have to
bunch
say.
Ooh, I might grab a mint. Am I allowed to get some?
Yeah.
The socks are actually my favorite because I'm not great about like tracking all of my socks and like keeping them together. So anytime I can add one to the pile, I'm a fan.
What type of medicine is this?
One way to find out.
Breath medicine?
One way. It's actually a grab bag. There's like 3 different medicines in there, and you'll find out. in
Hello.
6:30
Hi.
minutes.
Welcome.
Evelyn!
I like the maze Faz quote.
How are you?
How you doing? How are you doing?
The maze is a nice touch until you actually want to.
Oh, I know, exactly.
It's like multiple times it's been like,
Hey, Evelyn, how are you?
Just next to you.
Oh, you did? Sorry.
No, no.
So what is Faz exactly?
So we are.
Besides being huge, right?
No, text.
Oh, you know, I found the text, yeah.
And we get the socks, my thing with the socks are, I tell everybody at Christmas time and at whenever, like, don't give me socks.
Cool.
Like, you know, a guy
So
knows,
everybody
when you get
does.
older, at some point you realize what boxes you like to
Yes.
wear,
Yes.
and socks,
There we
and
go. I was
I'm
like,
like,
Once a year.
Like, you look for pretty much
Mine might
place where I
be
type
overdue
in
for
that.
some new versions, but still,
Exactly.
either way, they're
Exactly.
all identical, they're not different from left to right, and
The
they're not
identical,
different looks.
the identical is like TV.
Yes,
Yeah, I
it's
can
so
notice that.
simple,
That
it's
was
like,
nice. It was a really
it's
nice
better than
event.
there was like a blind joke, I remember someone telling me,
For having
how many socks does like,
I'm
if there's
hoping more
you
people
know,
show
if
up.
you got like a blind
Oh, this
brother,
is
you
your
ask him
event?
to go get you some socks or
So,
something, right?
yeah,
And he's going to get
like,
some, how
I'm
many
trying to
socks does
get
he
a
have
bunch
to
of
get
geeks
to get you a
together,
matching
talking
pair?
about geek
And
stuff, like, once
you
a
have two
month
different
or
types
so.
of socks. And,
The past
there's-
couple.
The answer, I don't know.
I have had.
No, but
geeks
They used to have
that
three.
last
It's,
minute. So
oh,
had-
no, I
had
think the way they set it up, they stage it as
Yeah,
if
there was
there's
a-
50 red
once
and
again,
50.
there was some struggles with that.
It's
For
just
some
the
reason,
fact that
nobody
you just
answered
need a
me.
pair, you need two of the same.
Yes.
And there's only two different.
That's the USB one. There you go.
What's
That
your
one.
name?
Yeah, man.
You Molly?
Yeah.
I'm Brett, nice to meet you.
Nice to meet you. Which company do you work for?
Here we go.
No,
I didn't want
started my own,
to. If I start walking, I just know.
doing like physical.
So they should have, yeah, they've had a cable. I don't have any tape to put.
It's okay. No. I just didn't want the.
Ideation, prototype,
big
just give them a little
knots.
taste of what I do. But
Okay.
I'll try not to trip.
Early, like so.
That'll make
Say
sense.
startups and stuff that maybe you have an idea or.
If you, if you do,
A change or something, or improvements and.
would this be
Yeah.
easier to like
yeah,
bring it
Yeah.
back around? If you could lift that up, I'll just.
So for the prototyping, where do you go to do the prototyping?
Here.
Let's say physical device,
My lab.
no lab. So you don't
I'm
have
just,
people.
just the different personalities. That's-
Cool.
That's all I got to work with.
Oh,
But-
okay.
No, it's just me, so I've got 3D printers, I've got.
There you go. You only have to worry about this little piece, and that's. As long as you don't trip on that, you're good.
All right.
I liked it. I've always been that. I've got thousands and thousands of dollars of different little computer chips. I mean, I've got a whole basement just shelves of parts. But I don't know. It's like not whatever the guy from Markvaldas. I'm not him, right? I'm like whatever. I probably wear different gear. But I just remember seeing him grab some parts bins on the shelves, and he seemed to always have. He could find from some of his parts bins whatever he needed, and that's like it's the closest I can say. Like, well, I kind of have that.
That is, that like, it's like, alright, this is what I'm reaching for now, like I have, you know, let me go down to the inventory, let's see what we got.
Like just making it. You see that?
I think
Well,
your
making
manager
communication
uses
headset,
something
whatever.
Huh?
For, like,
Your manager
construction
uses
workers and stuff
something.
like that.
File object and block. You forgot the block.
That's not my. That's not my slide.
Run before some different technologies.
If you represent that, so you should have it.
Stuff.
Mike.
Yeah,
Mike's poster.
roll together parts
and
and
see how-
threw a different one together
I call it
from
MCL,
evening
that's what
until
we
the morning
call
show,
it.
working set of three prototypes.
I think I should go back to my car and grab
It's like,
my
that's the
laptop then.
value
What?
of
Because
having
sitting here for all
things
those
on hand.
sides would be.
Cause you can go a million miles an hour or don't have a block.
You know, like, and just like being, just like, innovate, figure out, like, there's no roadblock, just move
You're right.
in a direct line to the solution.
It might not be your refined, like this is better for sourcing, you know, but it's, at least gets for the proof of concept. So it's not up with it.
Very cool.
So yeah, so yourself?
Oh, so I'm an engineer in VAST.
Uh-huh.
So basically, it's a data platform, but really intended to be really one platform for all the world's data. So like structured, unstructured, semi-structured. We do a lot in like the AI and accelerated computing space. So really big in GPU, HPC workloads. And there's a lot that we build out basically to, as data kind of comes in, give like life to it, give structure to it, automate like workflows. So, yeah.
Also, I didn't know you guys do ETLs.
So we're building out this capability. We call it the data engine.
ETLs?
Extraction transformation load.
I'm not always great with all the technicality of certain things.
This is all good.
No, you're good. You're absolutely. Thank you for asking. Honestly,
yeah.
like that's much better than just like playing along and have no idea what's going on.
The old like smile now. So in like the data space, it can be a huge barrier. Like, all right, I have data from one source. For me to make use of it, I have to transform it, right? I have to like clean it, and I have to move it somewhere. So basically, we're trying to build out all these capabilities in addition to being a place where all your different types of data are stored, we're automating the whole process of like curating it, cleaning it, like loading it. We do a lot with like the large model trainers in the world, so.
So is there still like, you've gotta have that human input at first, determining like how to categorize this data, what is this data relevant to your?
We have not automated ourselves out of a job yet. That is the ultimate goal. But yeah, so if you're, if you have like a factory, right, you have all your data sources and all the different things, you can, basically script it, we're building up capabilities, you can script it out, like, right, this data, this data,
My friend
this
from
database over here, what's this?
Oh, yeah,
It's in,
sure.
this data set.
He invited us to this
This data set.
He's a photographer around this
Oh,
process.
okay.
Again,
Oh,
so,
wonderful. Yeah.
there's a lot that we're doing. At the core, it is just like a very, very large, very, very fast.
Long time. I don't know what you
And then we're basically building all these intelligent.
Good opportunity to come hear about.
So I do a lot of stuff
What's got
myself,
going on?
just like AI, interesting.
AI and
But I'm always looking for.
As you know, I freelance full time, so it's like I have an interest rate in my.
Or like stuff like that, or like I
Uses
like
AI to do
the
something when
Microsoft
I'm
one
like
too.
bored or just like not having anything going on.
Azure, or
It's funny you mention that.
There's so much I can use for free.
No, for
I'm
like-
just wondering like, cause that's like
okay.
that take
Or
like,
like,
that's like, you know, how you
Well,
something
yeah,
like.
I mean, I don't know. What it would
It's
be,
interesting,
like something.
it's nice being
I mean, I have
aware
sales
of
experience.
Yeah.
paid services and stuff for like, customers or
It's kind of like
I'm here
finding
learning
something
about
that I would
different
still be passionate about.
things out there.
But use it.
And also like integration comes in like some like the strange
Tools,
places,
different
right?
tools.
Absolutely.
So, like none of these, we would like to say like we're.
Spend a couple hours a day maybe and like get something up and going, right?
Large scale model training, but also
Good
like,
place to get
a lot
started.
of HPC, a lot of quantitative
Yeah.
science, big ideas like
Meeting with
integrating
other people that are doing stuff.
So, I actually just copied a bunch of home
but like,
photos from
there's
way
nothing-
back when.
I was like
up
saying
to
we're talking about,
a
like,
drive,
the first
and
time
I'm trying to figure out
like,
like,
customer
how do I
prospects,
categorize
looking at the architecture,
without having to go through each
same
and every
building
one?
blocks.
And I was honestly looking at like seeing these language
In a
models.
new way, like we
That have
we
this
like
picture
same
recognition,
ingredients, just
so
done
they
with
can
different
tell who's
The
in the
main,
picture
like,
and like what's the
different way,
picture about. So they can describe the picture, tell a story about the picture.
What's the?
Wow.
And I was gonna try it out.
The really,
And,
the really
see
simple
how
version is
good is
in like
this?
large scale like enterprise.
Which might be something that would be an interesting
Yeah.
talk, right?
Things
Like,
that bundle together for a
Kind
while.
of able to create.
Like, look at,
Yeah.
I
You basically
took,
create, built your own software program using
I took my photos from Mexico a couple of years ago, just to get in, see what happens, and I'm like, oh, look at
And
that,
it was,
here's gonna tell a story
there's
about my
underlying technology
my
that
show.
makes it possible. We've decided we
Chris used to work at the university,
Yeah, and about.
So before they would add a module that had a bit of everything, so it
for
covered
like
each
their de facto
sector.
AI.
Yeah. And then,
come back
all the
home.
intelligence is
That's the joke
focused,
here.
containers, really dense, network.
Actually, I came here for university, but like,
Oh, okay. Right, Sheboygan?
Sheboygan, yes.
Modularly. And then the big thing for us in our space is,
Oh, wonderful.
a lot of this is like,
Ooh, great.
now and we're automating transformation data.
Okay, I will come down and help you, okay?
Broken everything. Now,
Need more hands?
you can add on more capabilities on top of it, like every process needs to be so. But we can do things that really no one else in our space can do because, we basically broke apart all of the building blocks. And then as you need more, as you're running more apps on it or more data, or you're getting more like data intensive, right, you can scale that part. Which is kind of unique in space. But, so hopefully there's some cross pollination, hopefully get some of that.
So is there some sort of like, like, I mean, what's coming to mind for me, if I'm thinking like normally you add a new, you know, whatever, block of the, you know, it's got the processing, it's got the GPU, it's got all this, whatever you want to call it, another segment or whatever, horrible words, but we'll just, we're rolling. So with the old school method, or the way everybody else has been doing business, they'd add one of everything, you know, just increase everything across the board when you might only need the one area. So is there something about your system that like monitors like the changes being added and has everything like kind of shift how it's doing, shift gears so it can adjust for just one area being added? Is that kind of, like if you, where your system's saying like, hey, I only need to add more GPU and everything, so I add a few more GPUs.
We'll talk about the architecture in
Okay.
the presentation.
Yeah, that's-
Yeah, and it's, so we're building out these like cloud capabilities now, but the majority of them are deployed in large scale data centers, so we will happily tell you, oh, you need to add this, oh, you should add that, but it's not like this like dynamic cloud resource for like, oh, well, as you use more X, right, like, it's just like scaled up. So that's something we've been building out like recently. Yeah, so but the super unique thing is that really it's like all data types, because historically you have basically, I always like you ever heard of like the jobs to be done theory? So like, okay, I'm doing work in the backyard, I'm gonna hire a pair of work boots for that. I'm going to a presentation, I'm gonna, another pair of boots. And we try to be one thing for everything. So in the sense of like, and this is something the guy I work with, that's not really. So on one hand, we literally work with like HPC centers and these like large quantitative funds that are like, we want to divide by zero. Like we want to like push this thing. There's other people are like, data, we don't know what we're going to do with it. We need to get like as much of it together as possible. We'll figure it out later. And we'll say like cheap and deep, and then we'll innovate on top of it later. So it's historically those are like really different ends of the spectrum, and we've been able to kind of satiate and kind of build towards both of those.
Interesting thinking about how it's really only been how many years that we've been really capturing much like data at scale like we've been doing.
I always like when they're like, oh, in the history of the world, there's X number of zettabytes, 99.9% of it has been made in the last. Yeah, this is. We were joking about we on the drive in today. We were like, we were just talking about the future, and it's like at a minimum, it's never going to be less. No one's going to be like, you know what? We actually have less data this year than we did last year. It's exponential.
Well,
Yeah, I think it's. How you doing, man? It's been a bit.
I know, you guys refused to do another.
We're putting together an official one. We were supposed to do one in Indy next week, but I think I have to go to some conference.
You're supposed to do next week and nobody ever told me about it.
And
What happened to the
he sent out a save the date.
if we're being totally honest, I'm trying to keep my head above water, and I'm not doing a great job of it. We're organizing a much more official one in June, where like we're gonna have people fly in. Like I was talking to, where's it gonna be? Oh, in Chicago, at the lineup of Pacific somewhere, because Paya Milos wants to bring a bunch of people, and we got like buy-in from like Sheik, Milos Paya from Billy, if like, but we need to like be around each other. So,
Well, the trust tree is broken, Dave, if you bring everybody in. No. The trust tree cannot grow more than we have at the moment. You can
now,
create
the
different
tree that does not bend, the tree that bends does not break. I don't know if you're familiar with this, but you want it to be able to bend. That's what keeps it strong.
No.
That's what I'm saying.
No. I
The
mean,
tree has to bend so it doesn't break.
do you know?
I have a lot of trees.
I know you do.
I have a lot of trees.
What's his name? You just made a line on it. The plastic white. Okay, yeah, him. You don't have, yeah.
We wanna give people a chance to grab something, then we'll get started.
That sounds perfect.
Cool. I don't do it in my face.
I don't think so either.
You want a little help, pepperoni,
Anything else is there.
got this
Put it on the
cheese.
side, nobody wants that.
Get pepperoni and sausage.
Ooh.
Chicken.
Buffalo is the one chicken is a big popular one.
You want the pineapple one?
No pineapple.
That's the only
What
thing
is
that
this? Is
eat.
that macaroni and cheese?
It's
Take a while looking at it. Another macaroni and cheese.
Stack those two.
You organize an event, you don't have a pineapple pizza.
That's an abomination of pizza. I can't get beyond that.
It's not for you, okay? It's for your.
Yeah, I can't even promote that kind of thing.
Pepperoni on pizza, okay? Like
Yeah.
pineapple pizza? Are you kidding me?
Macaroni and cheese, however, fine.
That's fine. Like,
It can't be that. It can't be.
That's all Italian.
You know,
right?
what happened when I come to Madison, I feel like the California vibe is going on in Madison here. So I was expecting pineapple pizza.
Pineapple pizza. Like, we don't have the palm trees, but we can work on that. Like,
Anyway, hi guys. Who wants here, raise your hand, hate or is against pineapple pizza?
Against pineapple pizza?
Yeah.
It's still pizza. How can you hate it? Like it's
No,
still
that's
pizza.
What else is on
He
it?
says disgusting, just pineapple pizza and cheese and whatever.
I would agree with that.
Is you
Nothing
against it?
else? No meat? Disgusting.
Discussing, discussing.
It's good with ham.
Yeah.
No ham, no,
Just pineapple?
no, just pineapple.
See, I used to-
no,
I used to be a fan of the Hawaiian where it would be pineapple and
Wait a
ham.
second.
no ham,
See?
just a bunch of vegetables
But the
and.
sweet, it's sweet
Yeah,
and
no.
savory.
Hard pass.
Live a little.
I was gonna
Live
say
a little. It's a big
cannibal
difference
not-
world.
So
Don't
none
be
of you
afraid.
guys here like pineapple pizza.
By itself, no.
Shame on you.
No, because it violates USDA, because pizza has to have
Look at me in the face,
all
Dave.
four. it
Look
has
at
to have
me in the face.
vegetables- it has to have vegetables, dairy, bread and meat, and pineapple pizza by itself. No meat, no pizza.
Where did pineapple pizza come from?
It's a flatbread. I think you're talking about a pineapple flatbread.
Yeah. Where does pizza come from? It comes from America. That's where it comes from.
Those Italians.
Okay.
We took it, I guess.
Those Italians. They don't know
Those
pizza.
Those Italian Americans.
Yeah. Anyway.
All right. I think I'm gonna give a few more minutes just to see if anyone else has perfectly been here.
No, actually, pineapple and jalapeno. That's actually an interesting combination.
So you have jalapeno pineapple on your pizza?
Yeah. It's actually a very interesting combination.
Oh, so you don't want the secret, you want hiding behind all these guys here. So you
No,
can
no,
eat
it
pineapple
wouldn't be,
pizza.
if it was there, and that was the only thing available, I wouldn't have any issue with that.
Next time I'll have a pineapple. I'll have pineapple pizza. Okay. Like it's a full of pineapple.
If I'm hearing
So
it.
does the jalapeno bring out something?
Yeah, it's a
Pineapple?
really interesting mix.
Kind of like the salt, like.
Actually, it's a Hawaiian with pineapple. I mean, jalapenos are.
By the way, I was just
Because there's gotta
messing
be
with you.
some
Hey,
sort
that
of
pizza.
Yeah.
cannibal, or carnivore, oh my god.
We are not on that.
I hate that pizza. There's no way someone can pineapple on their pizza. Most disgusting ever created. Anyway.
Who invited this man?
You did.
It's
No,
good,
no, Andy did.
it's good to know the flavors and things like that.
Exactly.
Man's out of trust.
All right. Well,
No, when you are in, you can't come out.
Hello.
hello. Come on in. Come on in. Did you see anyone else downstairs or? No. Okay. All right. We do have a number of people online, so I figured there might be some people that decided that making the trek through traffic is. And well, they clearly had ESP because to know that I did not have pineapple pizza coming, that was really impressive. Anyway, you're correct. We do not have pineapple pizza, but everyone that's not here, just know that you're missing out. We have some great Ian's Pizza here, sponsored by Vast Data. They're a great company, and they're going to be helping they're going to be giving a great presentation today. So first off, welcome to Mad AI. Quick show of hands, who else has been here before? All right, beautiful. We've got half our group. That's wonderful. The others that haven't been here before, welcome. If you're a fellow geek working on anything in artificial intelligence or trying to understand that, you're in the right place. So welcome. So Mad AI is really a group by geeks for geeks, and we try to give a use case and talk about artificial intelligence. And today I'm so honored to have Vast Data, and we have 3 people that drove up from Chicago to be here at this event and talk about their artificial
their AI platform. It's not just a solution, it's a platform. And I'm really excited about what they're going to be talking about today. This has been a talk that's been in the making for a number of months, and I'm just so happy that Andy helped organize this and he made it happen. So thank you so much. I so appreciate the help. And I'm really excited to have Andrius give a talk. Without further ado, please take it away.
All right, thank you. Thank you, Chris. Okay, so I'm not in marketing, and usually you start off these presentations with a slide about yourself a little bit with the speaker, but I thought I'd do a little something different here, and I went back into my old decks and I pulled out the last slide I did right before COVID at a conference or a presentation, something like this. So this data is from you can see 2020. And I worked about 20 years in proprietary trading at a couple hedge funds in Chicago, working building out database platforms, database technology systems, and doing a lot of modeling. I have a kind of a STEM background, and for that presentation, I actually built a model, trying to forecast recessions. And part of the reason I built this out was when I left formally the trading industry. I traded my own book for 7 years in the energy markets, so I had to do a lot of forecasting. I built a lot of models. There was a group of us, and I'm gonna hold the reveal till the end, so you guys can't leave to get what the outcome of is. I was actually, like I said, this was done in 2020. It's been a long time, and I was actually kind of interested to see just how well my forecast actually turned out. Oh, so on the right-hand side, this is just a log scale of the Dow Jones Industrial Average.
Okay.
And the numbers 1903, 1907, those are essentially recession, or at the start of a recession. So the idea here is to kind of to model and see and forecast kind of where the Dow Jones Industrial Average is going to go out. And I know we're the world has changed quite a bit just from an AI perspective. A lot of this back in the day was more, deep learning. No, LLMs really were just an academic concept. Now it's generative AI, predictive AI. These are all kind of, I look at it kind of as buzzwords, but it's essentially you're trying to model the environment in a mathematical representation. And the thing that attracted me to VAST, because I did work at Vertica, I worked at Snowflake and Yugabyte in that time between the trading industry and today. But I'm just going to kind of try to point out things to consider, when you're dealing with generative and agentic workflows, and kind of some of the kind of the showstoppers or kind of bottlenecks that you start kind of running into. And VAST is a massive ecosystem. I'm not going to cover all the topics today. In fact, I'm just going to cover a small fraction of it. We're going to look at some code, things like that. And I'm probably just going to concentrate maybe talking a little bit about the vector space that we actually provide in terms of a protocol that's kind of native to the system. And I'll get into a little bit more detail on that. But certainly we can cover all these. I'm sure if you're in the space, you know exactly what's causing these issues and the bottlenecks that it presents itself. But VAST in itself is really an amalgamation of these four things. Now, in your environment, you probably are running different systems. You're probably running an independent database. You probably have a key value store somewhere. You have a Kafka environment as an enterprise bus or Red Panda or some other type of streaming service. Obviously, you probably have some type of hardware that's dedicated to this kind of what I used to call, big iron storage, NFS, S3. And, the vector database has been around for a really long time. Part of my interest actually in joining VAST was because of this capability. When I was back in graduate school, that was kind of a project of ours. In the group that I was in was actually to write kind of a recommender system based off of embeddings, stored in a vector system. And back in those days, you kind of had to write a lot of this stuff yourself. And let me just get out of here. So why vast database or vast data platform? I think the best way to think about vast data is actually from kind of the history. The founders really were kind of looking at, they came from a storage background, and one thing that they noticed was that if you think about storage and database systems, they almost operate in two separate entities, but they have to have similar capabilities. When I was building out database platforms, talking to the storage guys was very important. Performance was a critical component. When you started running into scale problems, you had to do vertical scaling, and if spinning iron wasn't enough, there were Fusion IO cards that you would throw into boxes, et cetera. So it became kind of a limiting factor in terms of what you could do on these systems. And then on the right-hand side, you had these database systems, and if you think about kind of the old NFS storage devices, you had to do backups of disk and things like that. Well, in the database world, you had to do backups as well. And then those backups were actually backed up on the storage devices. So the founders were kind of thinking about, how, it's kind of I kind of feel like it's a bit of a hokey term, like a thinking machine, but they were kind of trying to think of, the storage system and the data system, they're kind of merging together. You kind of have to build a platform that can accommodate all sorts of data, structured, unstructured, semi-structured. You can't have data siloed. You have to have it in one location. And the concept that they came up with was, we're gonna first think about these things in terms of a protocol. If you think about NFS, S3, file systems, what are the three operations that every single one of them has? It has put, a get, and a delete. And when you think about database systems, SQL has been around since 1971. There's only technically 4 things you can do with it. You could select, you could delete, you could insert, and you could update. And an update is really just a delete and an insert. So if you think about it, the way to conceptualize what data and what VAST is that we treat everything as a protocol. So NFS, S3, block, database. We have a Kafka compatible broker. Again, you're putting things on the Kafka broker, you're taking them off. Get, put, these are all concepts, and the interfaces that we build for them are the same across all these protocols. So you can think of it as kind of a unified platform for storing whatever type of data that you need, whether it's structured, semi-structured, or videos or files. We can handle it all. You having some issues with
Yeah, I just realized that it's not actually playing our. I'm just going to move it to our browser. Okay, so we're going to do this, and we are going to. Which slide? This slide?
Yeah, you can leave it here.
Okay, and I'll just do this on the. Okay, thank you.
Yeah, no problem.
Make a question?
Yeah, sure. Yeah, while we're waiting, go ahead.
Yeah, I think you mentioned semi-structured data.
Yep. JSON. I mean, essentially, think of any type of data that's out there. You can store it into our system. Whether it, and I hate using the term database, because database means different things to different people. There's eventual consistency database, Cassandra. I look at, again, the easiest way to understand the VAST platforms to think about it in terms of protocols. And the way we store, for example, structured data, we're not putting it into a Parquet file underneath the hood. We're leveraging the PyArrow columnar format, Apache open source. And you can think of it as essentially a gigantic system to hold thousands of file tables or tabular format. You could put videos up into NFS, you could put videos into S3. And those tables, if you underneath the hood, if if you think about and if you understand how S3 works, like in Amazon and et cetera, it could scale to infinity. So that table can scale to infinity. A Kafka broker can scale to infinity in the system itself. And we'll jump on to the GUI interface and I'll kind of show you a few things and we'll kind of run through some code examples. Does that answer your question?
All right.
Actually, if you want to just stay up there and just click next.
Okay.
So yeah, this is essentially, so this is essentially our system. We started out with the data store, S3 NFS. We built out a tabular format for some of the use cases that we had. And you can really think of us as a transactional data warehouse. I'll get into what that means in just a second. The data engine, there's a lot of components there. We're going to be building out functionality. But the best way to think about that is, in the simplest case, as an event broker, where, for example, let's say you load up a file into an S3 container. It fires a notification, and you can put it onto a Kafka broker that goes and calls something to do something else. All that can be done on one system. You don't have independent systems and having to manage all those independent systems through an interface. And then finally, we have something called data space. The thing about VAST, and from the very beginning, was to eliminate tiered storage. We'll get into it in a minute about the hardware, but essentially it's an all-flash experience. You don't have hot and cold areas. It's all one unified environment, and you can actually replicate clusters globally. You just don't have to be siloed into one area. You can actually, and again, this is a very large topic, and I'm really just kind of blasting over a lot of these areas. If there's specific questions, we can always talk about it after the presentation. So, really quick, the only reason why I have this kind of dual control setup was how disappointed I was when I first started using it in the sense of just availability. Nobody does, I mean, from a storage perspective, nobody does this. But the reason why I have it on there is because it really kind of mirrors a lot of the standalone systems that we have now. You could eliminate the shared disk. But the key thing the thing that I really hated about this was that if you had the controller fail, the CPU and memory go out on the system and you were failing over, it took minutes to bring up the other system, and that just didn't work. So shared nothing, I lived in this space for a really long time. Everybody should really, I'm assuming everyone's very familiar with this architecture. The key thing, it worked for a really long time. This is back in when everybody was talking about the 3 V's, velocity, veracity, volume. It's still, eventually, after 64 nodes, 128 nodes, network issues, there's a lot of east-west traffic. The optimizers that were written for it really try to determine, how to run it fast. There was always these lags. The Snowflakes of the world, the Verticas, the Yugabytes, I worked at all 3, they operate on this model. So there's always going to be a bottleneck eventually in terms of where scale comes in. And if you're going to be dealing with AI, you really have to start thinking about how much, anybody can do 3 to 5 petabytes now. However, we operate in the 100 to, in fact, we have customers in the exabyte range that are leveraging the system. And I think, statistically, I don't know how many of the, the majors, the major LLM develop shops are there, but we have the, over 90% of them are actually using VAST as from a storage perspective for their inference, and model development as well as retraining and things like that. So everybody knows, that if one system goes down, things get kind of obviously take a performance hit. And again, I always think about it, shared nothing systems. The best way to kind of describe it is that they're local data only. The CPU and memory only has access. Even though there's multiple copies, it's really just access from one device. So we came up with a concept called disaggregated shared everything. And the key concept here is that, obviously we bifurcated the CPU in terms of compute and storage. But the interesting thing here that we did was that we enabled an NVMe fabric between those compute and storage devices. And in those storage devices, we're actually using storage class memory and SSD. So we're not talking about ephemeral memory, we're actually talking about physical storage. And this is can be its own talk track as well. So I'm really gonna fly through it. But the thing that this enables us to do, especially if you can think about it from a table perspective, is that from a database side of things, you have a fully ACID compliant system because we write twice into the SCM. So you could think about it as an incredibly large write buffer. And then we have a background process that eventually stores it into QLC flash. But the important thing that I want to point out in this architecture is that every single compute node has access to every block of data that's in the system. And we have an extensive metadata cache that essentially each compute node is aware of exactly where the data block is. So there's no more bottlenecks that you get in the shared nothing architecture where you're kind of limited to the data that you have on your disk subsystem. Each CPU has access to whatever data block in wherever it resides over that NVMe fabric. And if you actually start getting a failure in one of the controllers, it doesn't matter. It just fails over to another compute node. And again, because it has access to all the data, you don't really see a performance hit on where you do see that in the shared nothing architectures because the other nodes have to start doing more work to process the queries. So it's a very interesting architecture. It's very unique in the space. At the moment, there really isn't anything like it. You know, the concept's been around, but it just hasn't been implemented pretty much by anybody else. And the way we get away with writing into storage class memory and being incredibly performant is that we have a different way of storing the data and indexing it in that storage class memory. We came up with a concept where we call it V-trees, and the thing about this is that you can think of it as a binary index, but it has a very shallow leaf system. So you can very quickly traverse the data and find it very quickly. Then it gets served up from the data blocks that are on flash. And there's a kind of a little bit of a diagram there. We kind of stored in 32 kilobyte data chunks. Again, this is a really large topic, and we could spend the whole hour talking about kind of how we implemented this. But what this has allowed us to do, and this architecture has allowed us to do, is that you get a lot of the data reduction, a lot of the deduplication right off the bat. And we came out with a very important concept where we're essentially doing a similarity exercise and deduping it even further. So I don't think about it in terms of compression, but I think about it in terms of just storage on disk. We vastly, even backups on other vendors that we have really close relationships with, we could even further reduce the data footprints just because of this architecture. I'm just wondering how much time I have.
You are good.
Am I good? Okay. So why don't we just quickly hop on to one of the test clusters that I have up here. So this is we have a VMS system, and you can see, there's quite a bit of information right off of the dashboard and the splash screen. And I'm not going to spend too much time. But you could just see here from the infrastructure perspective, you have complete access into the whole environment, the C nodes, the D nodes. But I'm gonna go into kind of the heart of the system in what we call the element store. And here, this is where you kind of define your NFS, your S3 buckets, your database objects, and you assign the permissions. If you're familiar with identity policies in S3, you can get very granular in how you're defining the permissions on object types within the system. And if you look at the database environment, now the thing that is really important to remember here is that These are all databases that are running on the system, the vast platform. And if you think back to some of the other systems out there like Oracle or Microsoft, and they're running instances, for example, of a database, all those instances actually have to carve out their memory and CPU footprints, and they block access to other instances to those resources. That isn't happening here. So we actually have a number of customers that are using us in multi-tenant situations that, from a database perspective, all of these are databases. If you can think about it in terms of schemas, these are all tables. Let me just hop into one of, this market data one. It's holding, let's see. For some reason I'm not. Oh yeah, so there you go. There's the table name, etc. All these are essentially running on the exact same physical footprint that is exposed through an endpoint. And I'll jump onto a Jupyter notebook in a second here to kind of connect and do some querying of it. But the cool thing, again, is that the Kafka broker is actually also a table. Now think about what the potential of this is. Now you could actually, in our environment, you're getting rid of Zookeeper, you're getting rid of the whole Kafka broker ecosystem. And essentially you can create a table here, and I'm gonna go through this in a demo. And I'm gonna ask people to pay a particular close attention to this question table and this answer table. But all these are essentially topics in a Kafka environment. We have a fully Kafka wire format compatible broker that producers and consumers can grab information from. And as I pointed out earlier, because of our data engine, you can, for example, have a file land in S3, fire off a payload to a topic, and it gets consumed by a process downstream to do something on it, or internally, the data engine can do some type of operation on. That's all right out of the box for you, no additional configuration, no additional hardware, and it scales. Any questions so far? I know, like I said, I'm kind of flying through this very quickly.
You said you wanted to pay attention to the question and answer. Those specific databases in the last on the UI.
Oh yeah.
You want us to pay close attention to them?
In this particular example, when I'm going to do a Kafka broker demo, and this question and answer, these are tables that I'm actually going to leverage in the environment. So think of, again, when I set up the Kafka environment, I'm going to define a topic, and the topic is going to be question and answer. You'll get it into, when you see it in the terminal, it'll make sense. So what's kind of the unique, probably the most important thing about our table environment is really, and a lot of the quantitative hedge funds that I work with are really leveraging is the feature engineering capabilities of the table. And it's in two varieties. It's the width of it. I actually have one customer that has over 50,000 columns. I have another customer that has several thousands of columns that have very complex types embedded into them. And the key thing here to remember is that they originally were Parquet customers. And with Parquet, every time you had to add a column, you essentially had to rewrite the file. When you add a column in a VAST table, there is no rewrite. It is an append. And the thing that always killed me when we added columns to systems, especially in the Snowflakes, the Verticas, the OLAP columnar-oriented systems, was backfilling all the historical data. Those systems were built for 10 to 20 transactions per second. There was a global catalog that would get locked up. Try doing a million row inserts or a million row update on any one of those systems. It'll just crash to its knees. In our system, all you have to do is just issue an update, And you could actually even, in this particular example, I've actually even gotten kind of sophisticated where I've calculated moving averages on the fly, et cetera, in just 1 or 2 seconds, whereas in other systems it would take, it's just not possible. Any questions? Does that make sense to you guys? Any questions? No? Another issue a common issue that we kind of solve for is, again, in the Parquet space, trying to concatenate files, memory pressure. We have a number of customers that actually leverage, they obviously have a Spark environments. They leverage our S3 protocol to move data back and forth and use it as a kind of a storage platform. We're also going to be introducing capabilities where if you remember the compute nodes, you'll actually be able to run those Spark environments on those nodes, as well as actually in the latest release, we'll have capability of running Trino clients on it as well. And just curious, how many database people are in the crowd, or is this all LLM or developer type folks? I'm just out of curiosity on the. Because I'm surprised I haven't heard anybody saying that, yes, I felt that pain before.
So I was curious about the schemas of the databases.
Yeah.
Right? So being able to change on the fly the schema, essentially, I'm thinking the backend schema must be set. It's not hard set. You don't have memory addresses. It likely is in verse. You have essentially you write your data and then you decide where it's going to go.
So the way it flows through the system, if you remember the storage class memory and then the QLC flash, we essentially write, and the way we get to ACID compliance is that we write into that storage class memory twice in 2 locations, and those the V trees, those very flat vertical indices, we update the metadata in those areas so they know exactly where the data blocks are, and we write in very small chunks, just because of the architecture and the capability of the infrastructure that it runs on. We can write in much smaller footprints. In Parquet, they're much larger file sizes.
Yeah, I mean that's pretty amazing.
Yeah.
Being able to write on the small instances, especially when you're dealing with individual cells. But then if you look at the storage capabilities, scaling to large files as well.
Right.
So it's an impressive system.
And from the, it's interesting you brought up the whole, right now you're kind of limited in terms of the cell size on the table, but in subsequent versions that we're coming out with later this year, each column you'll be able to, I think right now we're looking at about 16 megabytes of, for example, if you have a 16 megabyte complex object type, you can write that into a particular attribute with no issue.
Wow.
So, a lot of people that are running on HDFS and other systems as well, they're really kind of really amazed at that capability and the speed up that they're getting. And if you have existing systems where they're leveraging the Parquet files, you can land them on S3, and the performance, because of our protocol and our architecture, it's actually it speeds up than your traditional hardware vendors. But we've seen when you move from those Parquet files into a database table on our system, we've seen instances where the speed up has been almost 20 times faster to download into the client a query request. Okay, and then we have a feature, Vast Insight Engine. This is kind of
I'm
yeah,
just going to interrupt
yeah.
just one moment. Does everyone understand why that's a big deal? Okay, so if you can get that type of speed up when you're dealing with column data, and if you're able to adjust your Parquet files when you're doing machine learning, specifically when you're looking at building up these complex neural networks, your read speed and write speeds are really critical. Specifically, as you're building up the model itself, right? You need to be able to write out your weights, and those weights are important to be able to write those out because you're going to want to checkpoint them in case you have a failure or whatnot. So being able to write those out regularly is important, but also the speed in which you read them in is your biggest bottleneck for any type of for any type of model building, especially when you're dealing with models that are, as you're talking about, like thousands of columns, 50,000 columns, that's a lot. You're talking about a hyperparameter space at that point. Being able to read that information quickly and being able to produce essentially that data on demand as you need it, and to build the follow-up model, the follow-up I keep trying to say language model, but this is beyond language models. These are neural networks, so deep learning, and being able to do that on a scale is really impressive. And that's part of the reason why I was super excited for VAST to be here, is that this bottleneck is something that's been around for a long period of time,
and actually that bottleneck, it's actually not solved at the table level. We just actually introduced a global key value cache, and that's kind of where we're storing like the snapshot information and things like that. It just came out. We could probably send some links out.
that'd be wonderful.
Yeah,
So,
for sure.
So this is exactly where the problems lie, is like being able to capture that data and quickly access that data is consistently a bottleneck for language models and for neural nets in general. So by VAST being able to provide that level of service and rapid access, I don't want to say it's game changing, but it's kind of game changing, especially when you're talking about these large data sets, because typically these large data sets are stored on Brown's disk, and then there's usually some sort of caching mechanism, and being able to pull that information off takes time. And now you're dealing with issues along the way, where what happens if the node fails, or if there's some kind of network issue on a given node that pulling information off. Like, VAST has really addressed all of that, and you kind of saw that architecture to showcase that one node can fail, and you don't have to worry about losing your entire run of as you're building up your neural network, and you're building up your model. And models are expensive to build. That's one of the biggest things in HPC is understanding cost in compute. Is like failures happen, and the fact that VAST can have a failure and it doesn't affect that compute is one less worry you have as you're building up your models. So I want to say kudos, and I just want to reiterate that that's a big deal.
So I'm going to run a model, or I'm going to leverage a LLM in the next demo, but I'm just going to quickly go over kind of an agentic workflow. This is actually a file that I, back in the day, had to parse and put it into. Well, actually, I essentially had to extract categorical variables to build a forecasting model. And this, if you take a look at it. Just curious, all right, I know there's not any database guys here. Are there any application developer guys here, all right? I mean, if you think about just getting a file like this, I spent 2 days trying to figure out how to actually parse this file and actually get it into a format that a numerical format that could actually then start building and evaluating models on. And when I got to VAST, we have a partnership with NVIDIA that we built out what we were calling an insight engine. And I'm just going to hop on kind of a splash screen here, or a GUI. And you know, I'm sure everybody is familiar with RAG pipelines. This is kind of part of a RAG pipeline demo where, let's say this NOAA data set wasn't there, I could upload it, and what's powering this environment is you know, a vector database. There's the Kafka event broker. You know, because a file lands, it has to do something. It has to get you know, all the offsets are stored. And probably in the interest of time, I might not go over those slides. But a nice thing about our platform is that you don't have disparate systems holding those offsets and vectors. It's all stored right next to each other. So there's no chance of actually having you know, data corruption, or you know, data just doesn't exist that's in the vector space and missing in the offset. But you could just kind of see here, and if you can follow, I'll just very quickly go through this, but I just actually started asking questions of this. You know, I uploaded the data set into our environment. You know, it got parsed. It got broken up, vectors got created, and then I started asking, questions about, hey, do you have, weather data? Can you get it from more states? And you could start seeing, kind of a pattern of information starting to develop that's getting extracted, from that file. And there's quite a bit. It puts it into a format. And, I say, what about the states, that you have for, asking specific questions for, specific dates, et cetera. But as I mentioned earlier, computers can only focus on ones and zeros. They can't, operate on text. So you have to actually start transforming these into categorical variables or numeric variables. And that's actually what I started doing with this system. And actually I started going, well, can you combine the data sets, because there's different dates in this file, into a tabular format? And then can you create, a legend? And this legend, can you then convert it into a number? And then after that, I'm like, okay, well, now that I got this information, can you create the SQL syntax to put this into VAST? And this was all done in a span of a couple minutes. So what took me 2 days, this system could just crunch through that number. And a lot of our quantitative hedge funds and things like that are leveraging these type of agentic workflows that really streamline the data processing pipelines in the system. And in the next example I'm going to do, this is going to be kind of a regulatory demo where I'm going to take a corpus of European banking rules. It's over 100 pages, upload it into the system, and we'll see how we do in terms of processing that. So, does anyone have any questions about that workflow? Okay, so. Yeah, go ahead.
So when you're dealing with RAG, right, one of the things you also are worried about is are there hallucinations along the way as you're updating or accessing that data? What kind of validation did you attempt? Or do you just assume that I mean, if you took only 2 minutes, I totally understand.
Yeah.
But like, what kind of validations would you want to do before you push this into
Well,
the task for that?
the interesting piece there is that we're leveraging NIM specific models, and what you're seeing in the field is that people are developing very specific models for kind of specific use cases. Like I have this generic test data. So the hallucination piece, that is a kind of a very important topic, but it's also a very difficult one to kind of control in these large language model systems. So you kind of have to, obviously, in that particular case, obviously there's kind of a human element that. That's why when you click on "Am I a robot?" or can you give me the fire hydrant, you're kind of doing Google's work on its training system. So obviously, the loopback feature into kind of retraining these LLMs are kind of important. It's a never-ending game in terms of trying to do that. But the nice thing about VAST is that it's actually a single platform, and you can do all that just from a single source of data rather than having disparate systems or trying to get that information from disparate systems. And in terms of the vector space, I did talk a little bit about the issues you get, in terms of data consistency when you're storing offsets and vectors in different systems. With VAST, you can store it in one environment. If you're leveraging something like, I'm going to pick on Postgres, PG vector, manually sharding, larger data sets, and almost every single system out there that I know of actually essentially is loading all the vectors into the memory. And essentially what you're doing there then is that you're kind of limited into the amount of data that you can actually put up into memory. And those systems become very latent in terms of it has to start bringing things up from disk. So it slows down. With VAST, all that is eliminated. The offsets and the vectors are stored in the same space. We're leveraging the compute and storage infrastructure that we have. Every single compute node, when it's processing the query, has direct access to the data block, and you just don't run into the bottlenecks that you had before leveraging systems that were built on legacy platforms. This was built from scratch in Vast. And I'm just going to jump then directly, because in the interest of time, just directly to the Kafka demo. And I'm going to apologize in advance a little bit, because I'm just kind of using a terminal here, or a few terminals, and then in a web page to kind of show what's going on. Oop. And I'm kind of doing it live. You could see here, actually, right before the presentation, I deleted the topics. If you're familiar, just curious, how many guys in the audience are Kafka guys? Or have used Kafka? No? Okay. Well, think of it as an event broker, and maybe you'll besides the reveal at the very end from that very first slide that I had, you'll get a kind of a flavor of what Kafka's all about. So, if you remember, I said pay particular attention to the topics, questions, and answers. So I essentially created 2 Kafka topics. One is for questions, and the other one is for answers. And the event broker is sitting on the Vast environment. And the important thing here is that when the producer sends something to the broker actually has a mechanism that it actually fires that question to an LLM, grabs an answer, stores it, and then I can consume it via a consumer. So let me kind of run through and tell you kind of what I'm talking about here. And I'm going to leverage this banking Q&A. As you can see, there's no data found here. And I'm going to fire up a producer here. That's running. I won't go through the Trino example. I'll just fire up a consumer here. Does that make sense? Producer, consumer, broker from a Kafka environment. The broker is essentially just a table in Vast that you could actually even run queries. You can't do that on other systems very easily. Let's see here. I don't know why this is not. I'm just going to.
How is everyone doing? You guys have any questions so far?
Just learning.
Just learning?
Anything today so far, Chris?
Of course, absolutely. Absolutely. So Kafka is really interesting in that essentially think of it as a FIFO, subscribing FIFO. So first in, first out, and you subscribe to different FIFOs to access your data. And that's used a lot in clearly in message brokering, but also in any kind of
IoT sensor data?
IoT sensor data, absolutely. Anything that you're looking at that might be temporal. So IoT sensor data clearly. Other things, monitoring systems, right? So being able to look at issues that come in, logs, potential logs, right? So those are great use cases for Kafka in case you're trying to figure out like where cybersecurity applications. Exactly.
So in this particular example, let's say I'm working for a bank, and actually this was a kind of a POC that we did with a bank. And I work in the regulatory department, and governments, federal agencies, they're always issuing memos, memorandums, updates to rules. It's an evolving environment, and just keeping up with it is almost inhumanly possible. But in this particular case, because we can leverage actually generative AI, we could actually upload those memos, the rules and everything, put it into a vector database, and I could write an agent where I could just, if I get a question, for example, from a client or a customer, I could just ask the agent whether or not it's compliant. What should I do? So I just had, I put together about 10 examples here. I'm just going to run one through because it's probably just easier to see. And in some ways, apologies. It's been a while since I actually had a talk live, and just it's a lot easier doing it at home on your home PC. So let me just capture one. So I'm going to fire this into the producer. So the question's fired, and it should show up. So what's happening here? The broker, and now you can see on the right-hand side the answer. So what happened here is that I fired a question into the environment. The Kafka broker picked it up, sent it to an LLM. It came back, and I had a consumer running, and I got an answer. A much easier way to look at it is now from an app perspective, like this banking Q&A. If you remember, there was no data into it. I just had recreated it. Now you could see, the customer asked me to move their reporting to a cloud provider. We already vetted. Do I need to document this? And the answer, from the regulatory documents came back like, yes, you do. And if you think about it, instead of having to look it up, you could even build this out where, the offsets and things like that it can point directly to the document. And what you can imagine here is that, you can actually have several hundreds of questions, or even, just agents that are running. I'm just going to just throw a bunch in here. So I've just threw in a bunch of questions, and you could see here, it automatically starts, coming back. That's how fast it operates. And if I just go and refresh that website, you could see, all the information just comes back, streaming to the consumer.
Is how a lot of the AI chatbots?
Yep, absolutely. Yeah. So if you in this particular example, it's obviously a banking environment, but let's say you log into any one of the commercial sites. When you have that annoying chat box pop up and say, hey, do you have a question? Generally, it's pretty very simple and specific just to that environment. But if you think about how many regulations are out there and how much information that has to be parsed and processed in order to get, and banks get fined for doing this incorrectly. So these have to be right. Cut to your point about hallucinations. There's a lot of work that goes into developing these LLMs to be very specific, especially in regard to.
People of that interaction too, right?
Right. Yep. So it's a federal regulation. Like even when you go to Chat GPT, et cetera. Not only do they have to store the question that you've asked them, but also the responses. And that's from a regulatory perspective. And then the provider or the people that are building these LLMs, they take that and, as part of their retraining of the models, or trying to evaluate the scoring and things like that and how well they work. And if you can think about it, like I said, we have customers in the exabyte data range that's putting together all this information. Any questions? Okay, so I think we're about at time. I'm actually going to jump to the very end and bring this up again. So just curiously, anyone have an idea on how you would maybe solve this problem? Like what the data sets, what would you use? Any ideas? Building these forecasts?
Well, historical data, of course.
Yep, historical data. Very iterative. There's a lot of iteration, a lot of feature engineering, building out these data sets. We talked about expanding out to 50,000 columns. We talked about complex object types. Feature extraction and things like that. But I don't know, do you want to know what the answer that I got and how I got it?
Is it go to 2030? I want to know the future now.
Yes, this is actually a forecast. Actually, I did this, like I said, I did this in 2020.
Point between your last plot. Okay.
That's the forecast. That was done 5 years ago. And you know what, actually, what,
Gas is gonna go down?
like I said, this was 5 years ago. This is actually even before COVID. Before, but I found that actually the more interesting piece was actually the piece of information. There was actually there was some feature engineering, but the feature engineering was actually just doing an offset. So you can think about, I'm actually looking for my code and data set from where I did this analysis, and just to see what the forecast will be for the next 10 years.
So it's
But- but-
energy markets.
Yeah, so if you think about just the price of crude oil and just do an offset by 10 years, that's actually, if you want to geek out a little bit, the correlation's over 80% on this when you run it statistically. And, like I said, I didn't remember the result. I spent more time trying to find this slide to present, but interesting result, isn't it? And this is even before. So you could just tell, like I said, I was in this market for 7 years. It is brutal. But it's, I think, a pretty good indicator for it. And maybe in the next presentation, I'll update this one, or I'll send it out to the group once I find my code and do the analysis all over again. So I just, I don't know if anybody else has any questions. If I guess we'll stick around and munch on some pizza or what have you. I think there's a door prize for attendance.
Yeah, so thank you guys. Thank you. Let's give it up for our speaker. And again, thank you so much for coming. I appreciate it. Your fellow peers appreciate it. It helps us, attendance is what brings me to continue this project. And I'm hoping that this community continues. So tell your friends, tell your relatives, tell your grandma, whoever you feel like. Just tell them that we're working on artificial intelligence, and we're trying to understand and build new tools and understand constraints and build from there. So again, I want to say thank you, VAST, for being here. Thank you for sponsoring this event, and thank you for having an awesome product. So thank you.
Thank you for hosting this and for building the community in Madison. Thank you.
Thank you, guys. All right, well, without further ado, enjoy your pizza, and thank you online.